Hello, this is lesson 2.7, inverse functions, and as usual, if you feel like you would like to pause the video, feel free to pause, and if you've got any questions, don't hesitate to ask. Um, okay, so yes, we're gonna start with the definition of the inverse of a function. So we've got f and g be two functions such that f of g of x equals x for every x in the domain of G, and G of f of x also equals x for every x in the domain of f. So the function G is the inverse of the function f and is denoted with, it's almost like an exponent, -1, but it is read f inverse. Thus, f of f inverse equals x, and f inverse of f of x also equals x. So the domain of f is equal to the range of f inverse and vice versa. And we'll talk more about that in a little bit. So we're going to go ahead and look at the example verifying or showing that each function is the inverse of the other. So we're going to start with f of g of x. So f of our g of x is x plus 7 over 4. So we're plugging that into our f of x where the x is. So 4 times x plus 7 over 4 minus 7. Now, the 4's cancel out. 4 divided by 4 is 4. We get x plus 7 minus 7. This is x. And that's what we wanted. Our so now we're going to go ahead and do the same thing the other way around. So g of f of x. So now if this ends up being an x also, then we know that they are inverses. Okay, so g of f of x is 4x minus 7, and now we're plugging that into g of x. So 4x minus 7 plus 7 divided by 4. Well, the negative 7 and 7 cancel each other out. We get 4x over 4. 4 divided by 4 is 1, so we get x. So g of f of x equals x as well. So we showed that these two functions are inverses of each other. Okay, next, we're going to look at the steps how to find the inverse of a function. So step 1 is replace f of x with y in the equation for f of x. Step 2 is to interchange x and y, and that's why the range of the function is the same thing as the domain of the uh, inverse function, because we are interchanging x and y. Then we're going to solve for y. If this equation does not define y as a function of x, the function does not have an inverse function, and this procedure ends. If this equation does define y as a function of x, the function f has an inverse function. So that's step number 3. Step number 4, if f has an inverse function, replace y in step 3 by by the inverse function of x. And now we can verify our result by showing that the function, the composite function of the f of x and its inverse equals x, and the inverse and of f of x also equals x. Okay, so let's go through these steps in this next example. So find the inverse of f of x equals 2x plus 7. We're going to replace f of x with y, so we're going to write y equals 2x plus 7. Next, we're going to interchange x and y, so these two right here. So we're going to write x equals 2y plus 7. Next, we are solving for y. So we're going to go ahead and isolate. So we're subtracting 7 from both sides. We get x minus 7 equals 2y, and then we divide by 2. So we get x minus 7 over 2 equals y. And I know that we could write it this way also. So when we are replacing the y with the f inverse, we can write the f inverse on the left side. And there we go. Okay, so when we tested if a function is a function, or if a graph is a function, we used the vertical line test. Now, for inverse functions, we're going to use the horizontal line test. And that is because we switch x and y. So a function f has an inverse that is function inverse f if there is no horizontal line that intersects the graph of the function f at more than 1 point. So basically the exact same thing we do for the vertical line test, except that we have a horizontal line test now. So if I go and draw a horizontal line, we can see that intersects in 2 points. So this does not have an inverse function because it would not, when we do the inverse function, it would not pass the vertical line test. This graph, on the other hand, only passes, or when I draw the horizontal lines, it only touches in one place. So yes, the has an inverse function. All right, so we've got graphs of, and now we're going to go ahead and graph them. The graphs of the function and the inverse function. So the graph of inverse function is a reflection, reflection of the graph of f about the line y equals x. So let's look at a graphing. Let me do a coordinate plane here, x and y. So the graph of function f consists of two line segments. One segment from -2, 2 to -1, 0. So -1, -2, -3, -1, -2, -3, 1, 2, 3. Okay, so -2 and 2 is the point here, and then we've got -1 and 0. So that is the first segment. Now we have a second segment, which is from negative 1, 0 to 1, 2. So negative 1, 0 to 1, 2, right here. So this is graph f. Now we're going to use the graph to graph the inverse function. So what we're going to do is we're going to flip the points. So negative 2 and negative 2 does not change because x and y, remember we interchange x and y. So this would not change. It's still negative 2 and 2. So right here. Our next point, negative 1 and 0, we are going to interchange, and we get, which means that we get 0, negative 1. So 0, negative 1 is right here. Then our next point, well, we continue with negative 1, 0, that we already interchanged it, so it's 0, negative 1. And then our last point, 1, 2, we're gonna, or it becomes 2, 1. So 2 and 1 right here somewhere. So this here is our f of x, and this one is the inverse of f. Now we need to verify that these are inverse functions, and that we can do by graphing the line y equals x here. And if when we look at it, it does go in the middle, and those are symmetric along that line y equals x. We could fold, if we had a paper, we could fold it along that y equals x, and the points would go on top of each other with these lines. Okay, that's it for this lesson. Let me know if you've got any questions. Bye.